Morning, everyone. Today is day 8 of Math 133, and we are going to be talking about Chapter 4, which is all about linear regression. So, Chapter 4 review is in your course pack on page 365. I think there's 4 pages. So, yeah, make sure you grab all that. Page 365, Chapter 4 review worksheet. Um, And next week on Tuesday, we're gonna work on the cumulative review number 2. So that'll cover everything from chapters 1 through 4. So that'll be a great way to cover because we've covered a lot so far, right? I know we've only covered chapter 2 and 3. Today we're gonna cover the chapter 4 review, but it still feels like a lot, right? All the material prior to the everything prior to the midterm. I don't know. I always find it feels like it's very fast, very there's a ton coming at you. After the midterm, it feels like the material we're getting slows down, but it's more difficult. So it's it's harder for a different reason. So um, just more complicated. So anyway, but today, chapter 4 review. Also next week on Thursday, the 12th, we'll start the sample midterm and we'll also start talking about the midterm and like all the details on when it is and how you can take it and what you can have and stuff like that. So, okay, so before we jump into the chapter 4 review on page 365, there's also a link in Canvas for the chapter 4 project survey. Make sure you take that survey. We're not going to use this until next week, Thursday, when we do the Chapter 4 Project 2. But I need that data. We need this data in order to be able to do that project. So make sure you come over here and it says submit the length of your forearm from wrist to elbow and your height in centimeters. So you click this link. Come over here. Here's a little graphic on what we mean by your forearm. So it's from your elbow to your wrist. Okay. So it's quick. First name, last name, how long is your forearm? How tall are you? There's a conversion for centimeters. So yeah. Um, anyway, we're going to be looking at the relationship and whether it's a linear relationship, right? Just like all the stuff we're going to be talking about today in chapter 4, the review, when we have two numbers. So here I have two numbers, right? Two quantitative pieces of data, which would be your height and how long your forearm is. And we're looking at whether those are related. Okay. All right. So let's come back over here and all right. So don't forget to do the survey. When you do the survey, by the way, this is in Google Forms, so it's not connected to Canvas. So Canvas isn't going to know that you filled it out. So it might appear that you still are missing the assignment. As long as you filled it out, you're good. I have to go in and see who filled it out, and I'll mark who did it in Canvas once everyone's finished. So don't worry if you're like, oh my God, it's saying it's late or behind or it's missing. So okay. All right. Chapter 4 review. Um, page 365. So if you click on it in Canvas, it'll bring you here. There's a link that'll bring you to this giant Google document that has all the different data sets for all of our different worksheets. There's one data set down here for StatCrunch. I'm just going to drop this in the chat so you don't have to go search for it. Okay. But if you're watching this on Zoom, you'll want to click on the Chapter 4 review worksheet, click on where it says this link, scroll down and find the Chapter 4 review worksheet, click on StatCrunch, and you'll have that data set available to you. Okay. Make sure you sign in to register, right, into StatCrunch, and so you'll be able to do the linear regression there, right? So, okay. I started grading some of the stuff. I'm always behind on grading, but um, take a look. There's a couple people that submitted the wrong assignment to the wrong to the certain things. So like instead of the chapter 3 review worksheet, they submitted, I don't know, the chapter 3 project. If that's the case, make sure you go and get that corrected. Okay. So just watch what you're submitting. So today, the chapter 4 review worksheet is this one, okay? Page 365. So make sure you're submitting this for the chapter 4 review, okay? All right, page 365. And just like on our worksheets previously, we're going to go through and I'll give you hints on where you can find the information, especially on some of the ones that I think are a little harder. And then we'll stop the recording. We'll go back through and we'll fill out all of the answers. Part of the reason I do that is, you know, you can watch me do all of the answers and, get 100%. But on test day, I'm not going to be there telling you like, hey, go to this page and that's going to give you the information you need. And so when you're studying for the exam, I don't want you to just look at the answer and be like, oh yeah, this is the answer. I want you to be like, okay, how did we get that answer? And if you don't remember, that's why I give, hints on how to do these problems. Okay. So today's hints are all going to be on page 255. Page 255 is all about linear regression. It's all the chapter 4 stuff. Okay. So the main thing that we're going to need is the stat crunch path, which will be stat, regression, simple linear. Okay. Now you can do a linear regression when you have two columns of quantitative data. Okay, remember quantitative means that you have numbers, okay, and that those numbers are numbers that you can do math on. You can do, you can do comparisons, you can do adding, you can do things like that. Okay. When you have two columns of quantitative data, like height and weight, or how much money your house is worth versus how much money your car is worth, you can compare those and see if there's some kind of relationship. Okay. How much, how many kids you have versus how much money you spend on clothing you know, each day or each year. Okay. You would expect that the more kids you have, the more money you spend on clothes. Okay. Um, so we can see if there's a relationship. Today, we're only going to be talking about linear relationships, but there are other types. There's polynomial and there's, logarithmic and exponential and stuff. Okay. They're all the same steps. Okay. Stat, regression, except instead of choosing simple linear, you choose, some other shape. Okay. And they're going to give you some correlation coefficient. This correlation coefficient tells you how good is that relationship? How strong is it? How likely is there something that is happening? Okay. Now the correlation coefficient can is going to be a number, but it can't just be any number, okay? So which of the following cannot be a correlation coefficient? What do you guys think? We on Tuesday this week, we had this whole project about looking at the correlation coefficient. One of these numbers is not allowed for a correlation coefficient. What do you think? Yeah, Rachel's got it. It is not this one, okay? Because you are allowed to have a negative, okay? But the lowest negative you can have is -1. This is -1.03. On page 255, there is a number line here that shows how strong your relationship is based on the correlation coefficient. And it says that, if you're at 1 or -1, it's a perfect relationship. You have a perfect straight line, okay? But there's nothing below -1. There's nothing above 1 here. Okay. So, yeah. that one is not allowed. Okay. In each case, circle and label the value of the strongest relationship. Also box and label the value of the weakest relationship. Okay. All right. So same idea. So uh, for part A, um, which of these has the strongest relationship? You look on page 255. Okay. Yeah. So you'll notice that, as I said before, you're allowed to have negative numbers. Okay. So the closer you get to one, so like if I have a correlation of 0.8 or 0.9, that is a strong relationship, a strong linear relationship, but it's positive, okay? Now over here, if I have negative zero point 0.8 or negative zero point 0.9, that is still a strong relationship, okay? So, uh, you know, that doesn't mean that it's a bad relationship. It actually means it's still predictive. It's still useful information, okay? Um, so an example of that would be uh, how, you're if I looked at, everyone's average speed when they're driving and how many crashes they've been in their life, okay? Um, you would expect that someone that has a lower average speed would have, oh wait, no, I guess that's a positive relationship, wouldn't it be? Um, so I guess it'd be how likely you are to get in a crash. So, yeah, anyway, that's a bad example. So let's see. What's a better example for a negative relationship? So last Tuesday we talked about the amount of time you spend exercising versus your weight. Like a someone who spends a lot of time exercising is probably going to be less is going to weigh less than someone who spends no time exercising. And so you would expect someone who does no time exercising will have a higher weight. Anyway, so that's still predictive. So for this one, uh, whichever number is closest to one or negative one. And so in this case, yep, you got it, Montez, Rachel. This number here, even though it's negative, if I ignore the negative, which one is the biggest? This one is. Okay. We also want to put a box around the weakest relationship. So weakest relationship would be something that's close to zero. Again, it could be positive or negative. So ignoring the sign, which of these is the smallest number? So ignoring the sign, which of these is the smallest number? Thank you. This one. And we'll put a box around that. Okay. All right. So for part B, so it can be confusing when we are looking at R because, like I said, it can be positive or negative. Okay. So if we square that, when you square a negative number, negative times a negative becomes positive. R squared is called the coefficient of determination. Okay. And it has a interpretation, which is again on page 255 down here at the bottom. We'll talk about that in a little bit. But R squared, the coefficient of determination, is always going to be a positive number because, again, when you square a negative, it has to become positive. But we can still look at it and determine which one is the strongest relationship, which one is the weakest, okay? And it's still based on which of these is the highest number, right? So if you take a large number like this, like 0.9, and you square it, you'll get 0.81, okay? If you take a very small number like 0 and you square it, you still get 0, okay? So the strongest relationship will be the one that is the biggest. So the biggest one here is this one, and we'll put a box around the one that's the smallest, okay? I'm going to skip past some of this, and I want to jump to page 366, and I want to look at number 5. A researcher wants to know if food insecurity, which is the percent of households that don't have enough food, they want to see if that affects the teen birth rate, which is births per 1,000 teen women in the U.S. Data are gathered from a random sample of states and shown below. Okay, so we have 2 columns of data, quantitative data. Okay, and so because of that, we can create a regression. Okay. Each row of this table represents what? So when you're looking at a set of data, um, each row represents something. Okay, maybe it's a year or a month or a person. Okay, and knowing what each row represents is important. Okay, it's going to be important for describing your data and also interpreting it. Okay, so each row here represents something. So, for example, this one right here, 10.8 and 10.6. These numbers go together. Okay? These are both numbers that were measured for something. Now, were they measured for a person or were they measured for, last, a year? So like this is the year, 2025, this is the year 2026. Okay? What does each row in the table represent? What do you think? Hey, you got it, Chanel. So you look at what were you sampling? What was your sample or what was your population? And in this case, they say that this is a random sample of states. So I don't know which state it is. Okay, maybe this is Michigan. So Michigan's food insecurity rate is 10.8%, and their teen birth rate is 10.6 births per 1,000 teens. Okay. So, and all these are different, right? Because these are all different states. Okay. So you look at what you're sampling. In this case, each row represents a state. Okay. All right. Let me skip past some of this. All right. The equation of the regression line. So to calculate that, that is on page 255 at the top. Okay. It's stat, regression, simple linear. Okay. So I dropped the link in the chat to StatCrunch, so you don't have to go and enter all of this data. I mean, it's not going to take you that long, but it would be a little annoying, especially if we had more data. If we were looking at all 50 states, then you'd have a lot of data enter. And so, just go here and you have the data in front of you and sign in, and then we'll go to stat, regression, simple linear. Stat, regression, simple linear. Okay. X variable is called the explanatory variable, and our response variable is our Y variable. Okay. And then we hit compute. Okay. And it's going to give you a ton of information. Okay. So for the question we're looking at right now, I want the equation of the line. Okay. So that is X and Y. So the equation of a line is Y equals mx plus b, where m is the slope because slope has an m in it, and b is the y-intercept because the words y-intercept has a b in it. I don't, which is just a joke. I
I
don't know why we use m and b for slope. Go, what is it, Elaine?
I was just laughing at you.
Um, uh, yeah, I don't know why we use M and B. Well, y equals mx plus b. You've probably heard that in other math classes. So it's this equation right here. Now, they don't use x and y, but we can replace the words teen birth with y and food insecurity with x. Now, you'll notice that it's not exactly in the right order. It's teen birth is my y, and then equals the M is the slope. It's the number attached to the X. In this case, food insecurity is the X. So the 2.06, that's actually the slope. And you can see that down here. They say the slope is this, okay? So anyway, I like to write my line in this order. So y equals, and the slope was 2.06. All right, what was it again? Just move this out of the way for me. 2.061 x, and then my intercept is negative 11.67. Okay. You don't have to write it in that order. You could write it in, the order that they give it to you here, which is negative 11, 6.75 plus 2.061 times x, just as long as you make sure that the x is attached to the 2.06, okay, because that is the slope. Now, how did StatCrunch actually calculate this? So if you hit this little arrow right here, it'll show you where the dots are for all of the states. And you can see that, they put a line through the middle of the dots. Looks like maybe we have one outlier up here. But basically what happens is in a linear regression, which, we're not going to calculate by hand. We're going to use StatCrunch, or, when I'm at my job, I would use Excel or some other tool. I'm not going to calculate it by hand, but what's happening in the background, what's happening in StatCrunch is it's finding the line that minimizes the total distance away from the line, minimizes how far away the dots are from the line. So this dot, for example, is right on the line. That's perfect. That's wonderful. This dot is, I don't know, it's maybe like an inch away from the line, or, you would calculate that distance. Okay. It's not measured in inches, but the point is you want your dots to be as close to the line as possible. Okay. So it's finding the line that minimizes the total distance that your dots are off of it. Okay. Because we don't want the dots all over the place. If we drawn a line like this, well, that would be wrong because I'd have a lot of dots that are very far from the line. Okay. Here, I've only got one dot that's far from the line, and then you're not going to be able to fix that because, this just has something's weird there. Okay. So anyway, all right. So let's skip down to question G here. Interpret the coefficient of determination. Coefficient of determination is the R squared in the context of the situation. You'll find that on page 255. There's a script for that at the bottom. Okay. And it says formal interpretation of the coefficient of determination. You write out what R squared is, but you write it as a percent. And you say that percent of the total variation in, and then you write out what Y is. And you say is explained by the least squares regression line. Okay. Food insecurity rate and teen birth rate are what kind of variables? So, what do you guys think? Food insecurity rate and teen birth rate are what kind of variables? Rachel says they are continuous, and I agree with that. Okay. You can only do linear regression or any type of regression when you have two columns of quantitative data. Now, they don't have to be quantitative continuous. Okay. You can do linear regression on quantitative discrete. Okay. You will end up with decimals because it's a prediction, just the same way that, like, if I took, if I took everyone's uh like if I took the number of pets that everyone has, that's a whole number, it's discrete. But if I did an average, I'm going to end up getting a decimal. Okay, that's fine. Okay. Okay, so based on the correlation coefficient, describe the direction and strength. So again, this is on page 255, and there's a number line for that. Okay. All right. Still talking about this. We're not done with this, but on the next page, page 367, continuing on, looking at food insecurity rate and teen birth rate. The slope and the y-intercept, all of these things, are these parameters or statistics? And that depends on if you have a population or a sample. And what do we have in this case? Yeah, I agree with you guys. Thank you, Rachel. Thank you, Stella. We have statistics because we have the word sample, random sample. If we had said all, that would be a population. Find the slope of the regression line. So one of these two numbers was the slope. Our slope in this case is 2.061. Explain what it means in the context of the situation. So explain or interpret, both of those mean we want a sentence, okay? And again, everything's on page 255 today. uh, page 255. And page 255 is part of the exam notes packet, so you'll get to use that on test day. There is a script for this. Slope script. That's in the middle of the page, okay? So the interpretation of a slope is if x increases by 1, and then you write out what the unit is, then y is expected to increase or decrease by approximately, and then you write out what the what the slope is, and then with a units. Okay, so they actually, so in the on this page they don't write mx plus b, they write ax plus b because slope has an a in it. So we're gonna use, yeah, either one is fine. Um, okay. So I'm actually going to write this one out. Let's do this one together. Find the slope of the regression line. It's 2.061 and explain what it means in the context of the situation. So I'm going to write this out. So using this script, so we write if, and then you write out what x is. If food insecurity rate increases by 1, always increases by 1. If food insecurity increases by 1, and then you write out what the X unit is. So what is the unit on my food insecurity? The unit is percent. So 1%. Then Y is expected to, right, so I'm using this script right here. If X, which is the food insecurity, increases by 1, and then I wrote out percent, then Y, teen birth rate, is expected to. Now, this right here, you write increase or decrease depending on whether your slope is positive or negative. In this case, my slope is 2.061. It's positive, so we will write increase. Now, if it was negative, I would write decrease, okay? And then when I get to this spot, I would drop the negative, okay? I'm not sure if we have an example of that today, but I think we have an example of that we'll talk about next time, okay? So don't worry, I'll show you what that looks like, right? Increase by approximately. So right here, you write out your slope, but again, at this spot, you will drop the negative if there is a negative, okay? And then you write out the units. What are the units on my Y? Units is births slash thousand teens. Birth per thousand teens. So my sentence is, if food insecurity increases by 1%, then teen birth rate is expected to also increase by approximately 2.06 births per thousand teens. Okay. That's what the slope means. Okay. Slope is always, if you move over by 1, you go up or down by this. Okay. All right, next, find the y-intercept of the regression line. So the y-intercept is not b, it is not 11, negative 11.675, okay? It is a point on the graph, which is 0, comma b, 0, comma, negative 11.675, okay? So if you don't include the parentheses 0, comma, you will lose a point, okay? So the y-intercept is where the line hits the y-axis, and that's not a number, it's a point, it's a coordinate, it has an x and a y value, and the x is always 0 for the y-intercept, okay? That's the definition of a y-intercept, is it where it hits the y-axis, and the y-axis always has an x value of 0, okay? But anyway, so why does the y-intercept not make sense in the context of the situation? So when you're doing linear regression, okay, or any type of regression, um, it allows you to make predictions and look at trends and see patterns, okay, inside your data, okay? Inside your data means somewhere inside that range, somewhere between the minimum and the maximum, okay? So in other words, looking at my numbers here, any number that's like along this line here, I'm okay with, okay? Because my lowest dot is like down here, my highest dot's up here. As long as I'm in between those, I'm doing what's called interpolation. Interpolation is a very accurate way to model your data, okay? Often, though, we are not asked to interpolate. We're often asked to predict what's going to happen in the future, what's going to happen outside of our data, okay? And that is called extrapolation. And extrapolation can be good, okay? But it can also be inaccurate, okay? Depending on, how far out you're extrapolating, whether you're using the right regression, things like that, okay? So if I was looking at a number that's way below or way above my highest and lowest points, so like outside the fences, right? We talked about that, outliers, then I could end up making mistakes, making, incorrect statements. So my lowest food insecurity is 9. Okay. When we're looking at the y-intercept, we're looking at a x value, which is food insecurity at 0, which is very far below. So in other words, we're looking at extrapolation. So it does not make sense in that case to use your line to predict that. Okay. So there's two cases on page 255 for the y-intercept. If it does make sense, you can use this script right here. Usually, though, it does not, okay? Usually, we're going to say when the y-intercept makes no sense, we'll say impossible for blah, 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 okay? And usually the answer here is going to be because x, it makes no sense for x to be 0, okay? And that's the case in this case. We'll say impossible for X. What was X? X is food insecurity to be 0%. Okay. It's impossible for the food insecurity of a state to be 0%. What does food insecurity mean? It means what percent of households don't have enough food to eat. Okay. So it's impossible for your food insecurity to be 0. There's always going to be, in every state, there's going to be homelessness. There's going to be people that are not able to provide. And so if a state had a food insecurity rate of 0%, that means every single household has enough food, okay? And we know, unfortunately, that's not the case, okay? Now, for this particular case, you could have also written instead, it's impossible for teen birth rate to be negative, okay? This is saying when your food insecurity rate is 0%, then your teen birth rate is negative 11 births per thousand teens. How do you have negative 11 births? You can't do that, right? That doesn't make any sense. Okay. So either of these answers would be fine. Most of the time we're going to go with this one, the 0%. Okay. All right. For New Hampshire, y equals 4.6. Find x using linear regression equation. Okay, so uh, in this case, they give us a y, and they ask us to find x. So what was the equation again? The equation of the line was this. Y equals blah, 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 right? So I'm going to rewrite that. So they're telling us that New Hampshire's birth rate, teen birth rate is 4.6. So we can replace y with that number. If you wrote it in pen, you can just rewrite it down here. 4.6 equals. So we don't do math in pen. Never do math in pen. Always pencil. All right. So we've got this, and they're asking us to find x. So we want to find New Hampshire's food insecurity rate. Okay. When you're doing these kind of things where you're plugging in x or y, make sure you pay attention to whether you're plugging in a y value or an x value. Here it's clear because they said y equals 4.6. But if they had said New Hampshire's teen birth rate was 4.6, is that y? Is that x? So just pay attention to which one you're plugging in, okay? To find x here, we need to do some algebra, okay? We have 2.06 and negative 11 over here. Both of these are on the wrong side. We need to move them over here. So we need to cancel these out. So which of these do I need to get rid of first? The 2 or the negative 11? You got it, Rachel. We need to get rid of the 11 first. So if you remember PEMDAS, this is the order that we calculate our numbers in. When you're doing algebra and you're like solving for x, we go backwards. So in this case, I have a subtraction. I need to get rid of that first, okay? So when you solve for x, you go the other direction. So I'm going to get rid of the negative 11 by adding 11.675 to both sides. You can do anything you want to an equation as long as you do it to both sides. As long as you're fair and you do it to both sides, then you can do whatever you want. All right, so these will cancel out and you get 2.061x. And then over here in your calculator, 4.6 plus 11.65, that's going to give you 16.275. Okay. All right. Now I've gotten rid of one of the numbers. Now I need to get rid of this 2.061. What do I need to do to move it to the other side? Divide. You got it. This is multiplied, right? 2.061. We always do the opposite. So if this is a minus, we do a plus. If it's a times, we do a divide. And again, you can do whatever you want. You got to do it to both sides, 2.061. Definitely not going to do that in my head. Somebody calculate this for me. 6.275 divided by 2.061. And then we get to cancel these, right? That's the best part of algebra is you get to cross the stuff out. And we get x equals 7.275. 900. All right. Show our work, give one decimal place. Oh, okay, fine. 7.9. And units. What are our units for X? Units for food insecurity is percent. If you haven't done algebra for a while, this would be a good one to study. Okay. How did we do that? So that on test day you're like, oh yeah, I remember to do this. Explain why the values found above are most likely outside the scope of the model. So outside the scope of the model, what does that mean? What is the scope of the model? So the scope of the model was what I was talking about earlier. I was using the word range because we're more used to that word. Technically, range is something else, right? It's the min minus the max. But you understand what I'm getting at. The range is what numbers are in the middle. Okay. So going back over here to my line, okay. Oh, great. So I don't want I want this. So here's my line, right? Right here is 9 for the x-axis. I just calculated that New Hampshire's x value is 7.9. So where is that? So if my x-axis keeps going, right? Here's 8. Can't draw with a mouse. Here's 7. Okay. So 7.9 and my food insecurity rate was what, 4.6? That's like way down here. So New Hampshire is this dot down here that I'm having a hard time drawing. Okay. This is outside the range or what we actually call the scope of the model because all the dots, all the states that I actually calculated this line on are over here. Okay. This one is over here. I'd have to extend my line, right, to get close to that one. And the problem with that is, so I put it at 4.6. It actually might be much lower. It might be down here. Um, when you zoom in on a specific area of your graph, it's going to look like a straight line, but it might be that this is actually a curved graph. Okay. And it's just that this particular section looks like a line. What we're doing here is, as I said earlier, we're doing extrapolation. We're looking at a state that is much lower. So the reason why, okay, explain why the values above are found outside the scope of the model. Uh, so x equals 7.9% is much lower than the food insecurity of the states sampled. So here's the states that were sampled, and all these numbers are like 10.8, 11.8, 13. Okay. Nothing in here is close to 7.9. 7.9% is much lower than the states that were sampled or measured. Okay. However you want to word that, basically the key is 7.9% is much lower. Or you didn't even have to say that one. You could have looked at the y values. Y value was 4.6. You could say 4.6 is way lower than any of the other measured birth rates. Okay. All right. Next page is page 368. We're still talking about that same data set. Alaska, x is 10.4, find the y value. Okay, so our equation was y equals 2.061, and we will plug in the x value. In this case, it's 10.4. So New Hampshire, they gave us the y. Here, for Alaska, they're giving us the x. 675. So we need to calculate what y is. So somebody, let's do this one together. So inner calculator. Go to Desmos. All right, so 2.061 times 10.4 minus 11.675. I get 9.759. All right. And our units here, don't forget units. Oh, give one decimal place. Oh, whatever. Okay, so it's 9.8. Births per 1,000 teens. That's the unit for Y. Interpret both values in the context of the situation. There's not a script for this, okay? You just use logic, okay? So you just write out what Alaska has. Alaska has a food insecurity rate of 10.4% and a teen birth rate of 9.8 births per 1,000 teens. Okay. You just write out what those two numbers mean, right? They give us X, we found Y. What do they mean? Put units on them. Right. Now, Alaska has a food insecurity rate of 10.4%. Yes. Okay, that's what they told us. A teen birth rate of 9.8. That's actually not correct. So we could have said, and we could say, and approximately, and an approximate teen birth rate of 9.8. What the line does, what the linear regression does, is it estimates where you expect your data to land. Okay, so this dot right here is right on the line. Most of these dots are not on the line. Okay, most of these dots are just a little bit off. This one's way off. Okay, the distance, how far off they are from the line, is called the residual. Okay, so maybe Alaska, we said Alaska was 10.4, so maybe Alaska is this one right here, right? 10.4. And it's estimating teen birth rate of 6.4. That's not the number that we estimated. The number that we estimated is the number that's on the line that's closest to that dot. Okay. And so if I want to know, okay, what was the actual number, I have to go and look at the data. So the actual teen birth rate for Alaska was 16.9 births. Find the residual. So that means find how far off we were. Okay. We estimated that it was 9.8. That is the predicted Y. Okay. So there's a formula for this on page 255 at the bottom. Okay. The actual teen birth rate was 16.9. So the residual is the actual Y minus the predicted Y hat. So you'll notice that this equation right here, Y hat equals AX plus B, they put a little like I don't know, a little caret kind of thing, a little hat on the Y. Okay. We didn't do that earlier, but we could have. Okay. I'm gonna drop the Y hat sometimes. Um, but the purpose of the hat, why do we put a hat on it? That doesn't make any sense. Just to make it fancy. The reason we put that on there is to remind us that that is not the actual Y value. It's a prediction. It's what the line is saying that the data or the number should be, um, or what it's going to be close to. Okay. So for this case, I need to subtract those two numbers. So what was the actual Y? The equation is actual Y minus predicted Y hat. What is my actual Y? Is it is it 9.8 or 16.9? Yeah, the actual Y is this one. What's my predicted Y hat? Predicted Y hat is what I got from here, 9.8. And if I subtract those two numbers, I get, what is it, 7.1? Give units. Births per thousand teens, okay? Now, your residual could be negative or it could be positive, depending on whether the dot is above the line or below the line, okay? Whether you predicted too many or too few, okay? In this case, our residual is positive, okay? What does the residual imply about the situation, okay? So first of all, our residual is positive, so these two answers are wrong. So Alaska is having more teen births than expected, or Alaska is having fewer teen births than expected, since the residual is positive. So this requires you to actually think. Okay. Uh, I mean, I want you to think, whenever you're doing math. Okay. I don't want you to just go into, memorization. I don't want you to just, watch me do it and figure it out. Um, you know, I want you to be thinking about the math and I want it to make sense. Okay. So their actual birth rate was 16.9. Okay. And we thought that they should be doing 9.8. Okay. So are they having more teen births than expected or less births than expected? Answer 2 or 4. Yeah, you got it, Montez. Alaska is having more than expected. We expected 9.8. That's what Y hat means. That's why we put the hat on there. That's telling you that's the prediction, but they're actually having more. Okay. All right. Fill out the correlation diagram fully. Include arrows and boxes for this scenario. Okay. So our X values were food insecurity, and our Y values were teen birth rate, and this is a correlation. Okay, correlation. There is a correlation between the two. What I mean by that is you can look at this line and say, oh, yeah, these dots appear to be headed upward. Okay. It's not a perfectly straight line, but it appears that there is some kind of relationship. That's correlation. Causation is when you have something that actually is causing it. Like, what's causing this to be high? What's causing this to be low? Okay. And that is not what linear regression shows. Okay. There's a sentence right here on page 255 that says correlation is not causation because there are lurking variables. Okay. So in this case, if a state has high food insecurity, that means there's not, there's a lot of people that don't have enough food, and they have a high teen birth rate. Okay. That doesn't mean that this is causing this. Okay. Is having too little food making it making teens have more babies. That doesn't make any sense, right? Higher food in the same direction with lower, if you have a lot of food available to you, so if you have a low food insecurity rate, does that doesn't stop teens from having babies, having more food, right? So this is not causation, okay? And that's because there are what are called lurking variables that are actually driving these two things. Okay? So what would be a variable? What would be a thing that would cause a state to have high food insecurity and high teen birth rate? Yeah. So socioeconomic, uh, income, things like that. Yep. Income or wealth. You only need to write one of these words, by the way. Economy, right? Uh, Rachel wrote socioeconomic. That's good. I like that. Any of these. So when a state is a wealthy state and they have a lot of money, okay, it means that they'll have enough money for people to buy food, okay? It also means that they'll have enough money to help teens, with contraceptives and to prevent, teen pregnancies, okay? We know that there is a relationship between poverty and having teens having more, ending up pregnant more often. So if a state has a low income, you have a poor state, then you're going to have a higher teen birth rate and you're going to have a higher level of food insecurity. And this is causation. So anytime that someone shows you that there's a relationship between two things, like, oh, this is really high and this is really high, so that means that this is driving this, and it's not the case. Okay. So people will often use that, the media and politicians, they'll use that kind of information to say, like, we need to fix the food insecurity rate. We need to fix this. We need to make sure everyone has enough food because, we have too many teenagers pregnant teenagers. Like that's not technically what we're getting at, okay? There's an underlying variable that you need to solve, okay? So anyway, I'm gonna stop the recording. We skipped over some questions. We did quite a bit of it, but we skipped over some questions. We'll go back through and answer those. But let's see.